So we have many techniques for factoring polynomials. So far we've just seen a few, but the first one we saw was to factor out a common factor that the terms in the polynomial share. And this is always the technique you should try to apply first. And we'll see why that's a good idea. So imagine I have to factor this polynomial. Well, first of all, right now, if I'd be just using this technique from section 6.3, I'm stuck because I don't have a 1 there. So we've only learned how to factor polynomials of the form x squared plus ax plus b. Okay, when the coefficient here is 1. So we'll learn actually in the next section how to factor polynomials where the coefficient is not 1. But even if there is a technique for that, the first thing we should try to do is look at the terms, like each term here, and see if they share something in common. Now, here there's x squared in the first term, x, and no x in the last term, so we can't take out an x. But if you look at the constants, 15, 75, 360, those are all multiples of 15. So actually I could take out 15 here. And if I do this, what do I get? I get 5 times 15 is 75. 360 divided by 15, I could do a little computation on the side. I divide by 15, so that's 2. 15 goes twice into 36, so I'm left with 6. After subtracting, bring down the 0. 15 times 4 is 60, and bingo. Okay, it's going to be 24, like this, and then I have an expression which is of a form that I can factor. So now I have x squared minus 5x minus 24. Coefficient of x squared is 1, right? So I can apply the method from this section. So I'm going to look for two numbers such that the product is minus 24. Sum is minus 5. So look at the multiples of 24. So 1 times 24, 24. 2 times 12, 24. 3 times 8, 24. And since the product is negative, right? One of these has to be a negative, so which means that this is actually the difference between the numbers. And I can see that the difference between, let's say, 2 and 12 is 10, but between 3 and 8, oh, that's 5. So those are the numbers we're looking for. So it's 3 and 8. I just have to adjust and figure out which one's the negative among these two. Well, the sum is negative 5, so it has to be negative 8 here. So that means that this is x plus negative 8 times x plus 3, and usually we write that as x minus 8, x plus 3. And that's our final answer here. And it's fully factored. And the other advantage of taking out the most general common factor is that I work afterwards with smaller numbers, right? The coefficient here, they become much smaller than they were initially. So I'm working with smaller numbers, and it's going to be a lot easier for me to be able to factor afterwards. So of course on a test I could always check that this is correct. So if I remultiply it, I should end back with what I had initially. So let's multiply it out. So x times x, x squared, x times 3, 3x, minus 8 times x, minus 8x, minus 8 times 3, minus 24, and that's going to be x squared minus 5x minus 24, which is exactly what I have here. So this is correct.